Hello, I'm Mark Zallen, team captain of the NSU Drill Team, and this is Team Tira's technical design presentation. So what we're going to be going over is the introduction on the team development and the drone specs, as well as retell the problem statements, and we're going to also discuss about the solution to the statements. So for the introduction, here is the full-on development team, as of course with myself as team captain, also part of the drone preparation team. Our advisor is Dr. Samuel Degwa, and we also have our airdrop group, which is, as you can see on the right. So the drone preparation group is basically the people who work on the drone as well as the software for the drone. And on to the right is the airdrop group, that basically people who have worked on the airdrop, finding ways and solutions so we can have like a better chance at the airdrop mission. So the drone that we're going to be using is the Firefly 6 Pro, is a copter drone, and the brand of the drone is a Bird's Eye View Aerobotics with a and the drone has a max payload of 0.7 kilograms, and it can be up in the air 59 minutes with a max speed of 65 kilometers an hour. The dimensions, the wingspan is around 152 centimeters wide and 83 centimeters of length. The weight is almost 4 kilograms, and it has 3 rotors. Its launching method is a vertical takeoff landing, as well as the training provided, and automatic launch landing is in the y-axis. The base station and software, for the communication of the drone, we use a high-powered ground station telemetry radio that has a radio frequency of 900 plus. And also for the software, we use a Firefly 6 planner, a Pix 4D mapper, as well as a DualShock for Windows, which is basically a software that connects the controller to the tower drone. That basically connects the controller to the mission planner so we can fly the drone manually if needed. So for the problem statements, we have the mission flight test, where the UAS must take off and fly waypoint paths. And the rules is you gotta stay 75 feet above the ground and must be 200 feet away from the runway. You can go below 75 feet if other runways are occupied by other teams. And also you have to stay within the boundaries within the mission flight boundary zone. For the flight performance, we had to fly 12 miles fully loaded weight in a single flight. You had to fly waypoints with max errors of 25 feet for each waypoint that you achieve. The turn radius of the drone has to be at 150, and the angle climb and descent has to be 20 degrees. For the airdrop mission, the UAS have to drop a payload at a specific position within target boundaries. The requirements, the drone can contain multiple airdrop payloads, but with one payload drop for each location. For the rules of this airdrop mission, the payload must be 5 pounds or less, and the payloads cannot have sustained flight, and the payload must land safely and must be safe for presentation and retrieval. So as far as solutions go, for the mission flight test, since the Firefly 6 planner has like a mapping tool software, we would probably have to plot in the boundaries as well as the waypoints of what they give us during the mission, and basically we will have to set those waypoints up to have the drone fly autonomously through the waypoints, and once it's flying through the waypoints, the drone will basically land safely automatically on its own. And once we do that, we get to go to the airdrop mission. As for the airdrop mission, we also have we combine two we combine two answers and basically into one solution. We have a water bottle casing, and the water bottle casing is made of a polyethylene foam, and that polyethylene foam is a case to protect the water bottle from damaging. The weight of the casing is 1.1 pounds with the casing, and also protects from mousing. For the reel and string, we use the reeling of the inside material of a real fishing rod, to basically try to have a try to have the payload drop a little bit slower, and not have like the gravity form, and not have like the gravity basically having the drone have like a hard impact. The handle of the reeling fish rod is not needed. As you can see from this video right here, as you can see, this is a video of the water ball casing protection. Now they had we have an old design of the casing and a new design of the casing, and what we did was measure the displacements of the target for each. The fall height for these attempts is 55 feet. As you see on the left is one example of the video of one attempt that we did. And so for the displacements with new design, we got less than 4 feet of the target displacement from the target to the water bottle. And as for the reeling drop test, we measured the time of the reeling of the water ball. Basically, lowers from how fast the water ball lowers from the reel. And as you can see right here, the drop times on the right side right here. It's basically around like 3.5 seconds. And as for the results of these, as a result from the airdrop thing, the casing protected the impact from the water ball from damaging. And with the new casing, provided less bounce distance. And plus of all, with the reel, it would make less of an impact on the ground since it's dropping slowing from the reel. And plus of all, and since the reel will be attached to a string, the string will also be released from the drone and the reel, basically providing less impact from the bottle to the ground. And that's basically about it. But here's our references, and thank you for listening to this technical design presentation.